All right, so now we're going to be talking about compound probability. Compound just means more than one. So our probability now is when we're looking for the probability that two events happen or more, 2 or 3 or 17. Okay, so compound just means more than one event. So they call, instead of calling their events E, like they did last time, they're now going to call them A and B. Okay, so this is just the probability of A happening and the probability of B happening. So basically, when you do this, you find the probability of A right here, and then you multiply it with the probability of B. Okay, so whenever you see this and, you just want to think multiply. Multiply right there. Whoops, that changed colors on us. Now, this is, let's back up just a little bit here. This is when we're talking about what we call independent events. So events that have no sway on the other event happening. So look at this first example. It says the dice is rolled 3 times. What is the probability of getting 1 on each time you roll? So basically, if you roll a 1, even though if you roll a 1 the first time you roll the dice, it doesn't make the probability any less for you to roll a 1 the next time. Okay, your probability is still going to be the same. So in this case, we're trying to find the probability that you roll a 1, then you roll a 1, then you roll a 1 again. So when we say an and, these are all ands right here, all we're going to do is find the probability of this first one, probability of the second one, probability of the third one, and multiply them all together. Okay, so I'm going to go ahead and even write it. So the probability that we roll a 1 right here, well, we know there's 6 numbers on a dice, and there's only one 1. So it's just 1 over 6. Now that's the same thing for this one. There's still a 1/6 chance that we roll a 1. Same thing with this one. There's still a 1/6 chance that we roll that 1. But if you want the probability that you roll 3 in a row, when we multiply them together, 1 times 1 times 1 is 1. 6 times 6 times 6, though, is 216. So that's a pretty small probability. You could also put it into your calculator. 1 divided by 216 is 0.0046. So basically, it's a 0.5%. 0.5%, not very big. Okay, so those are when our events are independent. You're just going to multiply them together. Now, dependent events is while you multiply them together. However, dependent events means that what happened second is dependent on what happened first. So there's a little bit different formula than this nice lovely formula here. You still do the probability of the first happening. That's still going to be just normal, just like this one was. When you multiply it, though, you are now going to do the probability of event B. But what you're going to do is you're going to say given, that line right up there, that's our fancy way of saying given that A already occurred. So you're going to assume that A occurred and find the probability of B. All right, let's look at an example of how this works right here. Jack had 4 Snicker bars and 8 Mars bars. So how many candy bars does he have? Well, 4 plus 8, he has 12 candy bars there. He randomly chooses a piece of candy, ate it, then chose another. What is the probability that both candy bars were Snickers? So we're trying to find the probability that he ate a Snickers and then another Snickers. Well, the first one is easy. The first one is just the same as before. You're just trying to find the probability of the first one happening. So our first one was that he ate a Snickers bar. All right, so how many total candy bars were there? Well, there were 12 candy bars. We want to know the probability he ate a Snickers bar. Well, there are only 4 Snicker bars right there. So 4 over 12 is that probability that A happens. Now we're going to multiply it by the probability that B happens given that A already happened. So now we're going to find the probability that he ate another Snickers, but we're going to assume that this first one happened, that he ate a Snickers bars. Now, here's where the dependent is a little different because he doesn't have 12 candy bars anymore. Remember, he just ate a Snickers bar. So how many candy bars does he have now? There's only 11 candy bars because one of the Snicker bars is already gone. Okay, and then we want the probability that he chose B. So there were 4, but remember, we're assuming he already ate one. So how many Snicker bars are there now? There's only 3. So when we multiply these together, 4 times 3 is 12. And 12 times 11 is 132 right there. So this would be a good answer. You could simplify it. This is really because 12 goes into there 11 times. So 1/11th, or you could even put it into your calculator. 1 divided by 11 is 0.09. Okay, so that's the probability that he ate 2 Snicker bars when he chooses them at random.